Okay, hi everyone. So this will be for this video will be for my calculus assignment. So what we're going to be doing is we're going to discuss a graph which is x to the power of 5 minus 5x to the power of 3. So first we're going to be finding the x-intercepts, y-intercepts, the intervals, which the function is increasing or decreasing, the x coordinates of the inflection point, the concave ups or downs, concave ups of the function, and the minimum and maximum points. More like the local minima and maxima of the graph. Okay, so after that, from these parameters, we're going to find the shape of the graph. So for now, we are supposed to have no clue of what the shape of the graph is right now. Okay, so the x-intercepts and y-intercepts, they're... Okay, we'll start off with these first. I'll make a new page. Okay, so first for the x-intercept. Okay, so for the x-intercept, let's fix it at y equals x 5. Okay, so this part is relatively simple. At the x-intercept, we'll just fix y as 0. So x5 minus x3 equals 0. Then we'll just solve it from here. So x... Oh, there's no x here. Okay, so from these, you'll know that one of the values of x will be 0, and the other one will have to solve x squared equals is minus 1. Okay, so x squared equals 5, and x equals to square root of 5. We'll just put it as a solved number, not in a root form, so that, you know, because it'll be represented as coordinates anyways. So since it's square root, there'll be a plus minus, and it's I'll go with 4 decimal places, so 2, 2, 3, 6, 1. Okay, so now we've got 3 points, which is okay, I'll write it down here. X equals negative 2.2361, 0, and 2.2361. Okay, so now we're gonna find the y-intercept. I'll make a new page. Okay, the y-intercept. So this one will be easier than in the previous section. For the y-intercept, we're gonna fix... Okay, so this is our function. Finding the y-intercept would mean that our axis would become 0. Okay, so 0, y. So it's 0. Okay, so we found our y-intercepts. So the y-intercept would the y-intercept is only 0, and this would come in handy in our point of inflection section. So you'll be seeing this number again soon. So now we'd like to see, okay, now we're going to go back to the now we're going to go on to the next section of this question, which is finding the increasing and decreasing functions within this graph. Okay, so in finding the increasing and decreasing function, we've got to differentiate the function that we've been given. So it's 5x cubed. So differentiating it would be 4 minus x squared. Okay, so now we're going to replace this with fx instead, so that it'll be clearer, like what are we subbing it into this x, because finding the increasing function would involve subbing stuff into these x variables. So now we're gonna put this as 0, 5x equals 0. Just to find the critical points. So square Alright, so I'll make a new page. Okay, so from here we'll get at least one of the x's will be the value of 0. So x squared minus 3, we'll have to solve this. So x squared. So that is plus minus 1.7321 in 4 decimal places. Okay, so now we've got our 3 points, x equals 0 and negative 1.7321, positive 1.7321. Okay, now we're going to put all these values into a number line. So like this, and then we can find the increasing and decreasing functions. Okay, so to find whether it's an increasing or decreasing function, first we've got to establish what are the positives and negatives in this number line. To find that, we can sub in any values that are sort of smaller or bigger than our critical points here. So these, the ends of this number line would be established as infinity and negative infinity. Okay, so we're going to be using the function that we've got here, 5x squared, x squared minus 3. Okay, so this is our function fx. Okay, so what's smaller than negative 1.7321, we can just fix it as negative 2. So f negative 2 equals 20. 20 is bigger than this, so it's a plus here. Now we're going to put something in between 0 to negative 1.7321, which a suitable one would be f equals negative 1. And that is negative 10. Negative 10 is smaller than either side of them, so it's a minus. So 0 to 1.731, we can put it as 1. And it's negative 10 here. So it's another minus here. 1.7321, the bigger version is 2. So it's 20, which is bigger than 1.7321, so it is a plus here. So now we can see the increasing and decreasing functions here. So these will help us later in finding the shape of the graph. So for now, we can see that the graph increases from infinity to negative 1.7321. It decreases from negative 1.7321 to 0, decreases again from 0 to 1.7321, and increases from 1.73 to 1 to infinity. Okay, so this is the shape of our graph. So the number line that we obtained just now, okay, so maximum points are when the increasing changes to decreasing, and the minimum points are vice versa, which is decreasing changing to increasing. So this would be a minimum point, and this would be a maximum point. Alright, so the next part would be in finding the concavity. So our function here is fx, x. Okay, so concavity, we'll need the second derivative. So first we're gonna do it as usual, differentiation, and the second derivative would be okay, so now we're gonna equate the second derivative to 0. So okay, so we will obtain x equals to 0, and the other 2 points will be solved from this. And that would be x equals 0 plus minus 1.2247. So just like in the previous section, we're going to put all these values in the number line. Okay, so to find the concavity, we'll need to sub the second derivative with values that are so more or less than what are our critical points here. Okay, so just to explain a little bit on the concavity, as a small explanation, concave up graphs in second derivative, they are increasing. Concave down graphs, second derivative, they are decreasing. Okay, so let's put all the values. Okay, so in a number line, we'll be using -2 here, -1, 1, 2. So it's 10x, 2x squared minus 3. So now we're just going to sum in the values that we have fixed here into this function, and then we'll obtain whether it's an increasing or a decreasing function, or in this case a concave up or down function. So if f -2, then it's -100. So this is a minus. If f -1, it's 10. So this is plus. F1 is -10. So it's less than either sides. It's -2. It's 100. So it's positive. Okay, so we've obtained our concavity here. In this case, the graph is concave downwards, upwards, downwards, upwards. Okay, so now we've obtained all the things we need. Concave ups and downs. Yep, so we've obtained everything that we need. So we can start drawing our graph. Okay. Okay, so as said in the previous part, these are our x coordinates. So it should be somewhere around here. And our only y coordinate is 0. So we can sort of assume that there's going to be some sort of point of inflection here, or it may be the other side. Okay. So in the first part of the graph, it should be concave down. It's a power line graph. So in the first part, it should concave down and it should intercept here. Okay. And then the second part, it should concave up. So if we're not sure, we can refer to the increasing and decreasing functions in the previous part, because it seems like we have a point of inflection here, so the shape would be more obvious by following something there. Okay, so it is decreasing, and it's a point of inflection as said here. Okay. Decreases, point of inflection. So this is the concave up, and the point of inflection is sort of like the up and down. So concave up, down. Then after that, the last part, it should concave up. So it goes this way. Yeah. So the x powered 5 minus 5x cubed, the graph should look about like this.